Last week we already learned about the resource planning. However, the resource planning has some disadvantage. It's quite rigid and it is slow to react to changing conditions. So let me give you an example. If a customer want a delivery urgently, we cannot just tell the customer to wait until we fit the demand the orders into the next planning cycle, right? For example, we are planning for the period A and that product is not included in this period. However, the customer want it urgently, so we cannot just leave it there and plan to produce in the next period. So the customer will have to wait long time. So to satisfy customer requirement, if we use resource planning, it's not so we cannot optimize the our customer service level. And the second one is when we try to make plan for the resource, we use the forecasted demand. Do you still remember forecasted demand or forecasted sale? However, in the reality, the forecasted demand or forecasted sale is often wrong. It's not really accurate. So that is another disadvantage of resource planning. And how we can improve this problem, to solve this problem, to improve the disadvantage, we try to match the supply of the logistics to the actual demand, and controlling material flow will help us solve this problem. So that's why we will learn how to control the material flow in this chapter. And we have two main methods to control the material flow. The first one is MRP and the second one is JIT. MRP stands for material requirement planning, and JIT is just in time. So let's go to the first content, MRP. Please remember MRP stands for material requirement planning. And normally how we will calculate the total demand. Do you know how we will calculate the total demand? So if we use the conventional approach to planning, we will calculate the overall demand for a product is the sum of all the individual demands from many separate customers, right? However, in some situations, this conventional method will not be accurate because the demands sometimes are not independent. So it means the demand of this product depend on the demand of other product. So that's why we consider two different kind of demand: independent demand and dependent demand. Okay, so what is independent demand? As for example, like automobiles or television or carton of ice cream. And independent demand often occurs at a constant rate. Okay, how about dependent demand? Dependent demand is like raw materials or components or the sub-assemblies, and the demand often occurs in lumps. So here we can see the constant and the lump here. I give you an example, a table. Let's say a table. So to construct a table, what do we need? We need one top, right? And 4 legs, for example. So which one is independent demand and which one is dependent demand? So for example, I want 2 tables. The order is 2 tables. So is it dependent or independent? the demand of 2 tables. It's independent, right? However, if we need 2 tables, we need to order 2 tops and 8 legs. And the demand for the tops and the legs depend on the demand of the table. So tops and legs here are dependent demand, and the demand for tables are independent. And MRP is designed when the lumps in demand are known. Okay, when the lump is known, it means when the relationship between the dependent demand with the independent demand is known. So how we can construct the MRP? We need a lot of information about schedules, products, and materials to make the MRP. And it comes from 3 main sources. The first one is bill of material. The second one is master schedules, and the third one is inventory records. What is bill of material? I will talk about the detail later, but the bill of material will help us list the materials needed for every products. So it's like here this example. When we need to make 1 table, what kind of material we need? We need 1 top. 1 table we need 1 top and 4 legs. So it's one example. The BOM. Okay, bill of material is we can shorten by BOM. So bill of material will give us the list of the materials we need for the products. The second one is master schedule. Master schedule will give us the number of every product to be made in every period. So in this period, how many products, how many components we have to produce. So it is what the information master schedule will give us. And the third one, inventory records. Inventory records will show us the materials that are available for our production. Okay, and here you can see based on how to make the master schedule. So based on the aggregate product plan, that is we already learned in last lesson about the resource planning. So based on the aggregate product plan and also the forecast demand from the random customer and also the orders from known customer. So we separate the orders from 2 sources. The first one is random customer and the second one is the known customers. And based on this information, we can make the master schedule. Okay, and based on the engineering design change, we can build the BOM, the bill of materials file. And based on the inventory transactions, we can build the inventory records file. And based on master schedule, inventory record files, and BOM file, we can make the material requirements planning MRP. And based on the MRP, we can write the report, like report about production, about inventory, so on and so forth. Okay. Let's see what is BOM. BOM is bill of materials, and it indicates all the raw materials, components, sub-assemblies, and assemblies required to produce an item. And BOM shows us the way a finished product or a parent item is put together from individual components. and we consider the finished product is at the lowest level, that is level 0, and the subsequent levels are parent components, then components. The production planner exploits BOM for the finished item to determine the number, due dates, and order days of subcomponents. So for you to understand more about BOM, let's look at this example. That is, I have a table, and to make a table we need one top and 4 legs, and to have the legs, to produce the legs, we need to have one wood kit and one hardware. And the same, to produce one top, we need one wood kit and one hardware. And to produce one wood kit, we need the oak planks, the pin siding, and the troll peg, so on and so forth. So this we call, this figure is the a part of BOM for a table. So table is the finished products. What is finished products? Finished products is the one we can directly deliver to the end user, to the customer. So here is table, here is the finished product. We also can call it parent item, or is in level 0. And the next one is it shows us the materials we have to, the component and materials we have to prepare to make a table. So the first one is the level 1, that is the component to make a table, right? And so on and so forth. We will have level 2 and level 3. How about master sketcher? So master sketcher, we base on the customer order and also the forecast demand, right? Do you still remember here? We base on the orders from the known customer and also the orders, the demand, forecast demand from the random customer. So based on to those factor, we will build the master sketcher, and it will the master sketcher will indicate when and how many end items will be produced. We can look at this example, the master production schedule for a family chairs. So look at this one. Based on the known customer order and the forecast demand, and also the aggregate production plan for chair family, we can see the aggregate production plan is monthly, the plan make for monthly demand. For example, in April they need to produce 670 chairs, and in May we need to produce 670 chairs as well. But for master schedule, we will make this schedule for week. So we want to know in each week in April or May, how many we should produce the products, the items. So here we can see that for the ladder back chair, we should produce 150 in week 1, and in week 2 we will produce 200 desk chair, or in the third week of April we will produce another 200 desk chair as well. So here is the result. Here is the master production schedule file, and how to construct it we will learn it more detail later. So here the master schedule will show us how much the items we need to produce and when. It's in week 1 April, or in week 6 we need to produce 150 leather back chair. Okay, that is what we use master schedule for. So let's look at this example. This is will show you the combination between BOM and Master Sketcher. So let's talk about the Board Sport company, and they want to make the sidewalk special. The sidewalk special. This is the photo of the sidewalk special. And to make, here is the BOM, right? The BOM of the skateboard. And to make one sidewalk special, we need one fiberglass board and we need two wheel assemblies. And to make wheel assemblies, one wheel assemblies, we need two wheel. This is one wheel assembly. So look at this. To make one wheel assembly, we need two wheel, one spindle, one wheel mount stand, and two lock nuts. So here, if we need two assemblies, we will need four wheels, right? And two spindles, two wheel mount stand, and four lock nuts. Okay, that is BOM of the sidewalk special. And here we know that the lead time. What is the lead time? Lead time is when you are start ordering until when the product arrive to you. That is the lead time. It means the waiting time when you make an order or when you produce. So for the sidewalk special, you need 1 week to complete it. For the fiberglass board, you need 3 weeks. For the wheel assembly, you need 1 week. The wheel mount stand, you need 4 weeks to finish it. For the wheel, you need 1 week. For the lock nut, you need 1 week. And for spindle, you need 2 weeks. So here is the lead time. So we can determine the material requirements to produce one sidewalk special. Now for the fiberglass board, we need 1 multiplied by the number of the sidewalk special, right? And how can you determine it? Is based on the BOM. So here I already mentioned earlier, if we need 1 sidewalk special, we need 1 fiberglass board, but if we need 2, here we also need 2. So the number of fiberglass board is equal to the number sidewalk special multiplied by 1. The number of wheel assemblies will equal to the number of sidewalk special multiplied by 2. And the number of wheel will equal to the number of sidewalk special multiplied by 2 and multiplied by 2. So it's equal to the sidewalk special multiplied by 4. So on and so forth, you can determine for all the materials that you need. Okay, like what I write it here. And now we need to let's assume that the order is 50 and we need to produce 50 sidewalk special. So we can determine how many fiberglass board, how many wheel assemblies, how many wheels, how many spindles, how many wheel mount stand we need. So if we need 50, let's go back to BOM. So if we need 50 sidewalk special, we will need 50 fiberglass board. We will need 100 wheel assembly. To have 100 wheel assemblies, you need how many wheel? You need 200 wheel, right? And you need 100 spindle. You need 100 wheel mount stand, and you need 200 lock nuts. Okay, so based on BOM, you know how many materials, how many components you need to prepare to produce 50 sidewalk special. So after you determine the number here, after you determine the number based on the lead time, and you use the master production schedule to see when they should start ordering and how many products, how many components they should order every week. So here we can see here in week 10 we need 50 sidewalk specials, and the lead time is 1 week. You can see the lead time table is here. So here I already mentioned earlier, like the lead time to make the sidewalk special is 1 week. For the fiberglass board is 3 weeks. So based on this lead time, we will make the master schedule for the products. So here the lead time for the sidewalk special is 50. So you need to uh, start. You need to have the fiberglass board and the wheel assemblies in 1 week in advance. So it means 50 fiberglass and 100 wheel assembly have to be ready in week 9. Okay, so to have 50 fiberglass balls in week 9 and the lead time is 3 weeks, so it means we have to start ordering 3 weeks in advance. That is week 6. So in week 6 we have to order 50 fiberglass boards, and to have a 100 wheel assembly in week 9 we have to, and for the wheel assembly the lead time is 1 week. So it means we have to have all the components like wheels, spindles, mounting stand, and slot nuts be ready 1 week in advance. That is in week 8. So we need to have our 100 wheel assembly in week 8, and to have 100 wheel assembly in week 8 we need to have 200 wheels, 100 spindles, 100 mounting stand, and 200 lock nuts be ready in week 8. And since the lead time of the wheels is 1 week, so we need to start ordering the wheels in week 7. So on and so forth. You can determine when we should start ordering and how many. So for example, the mounting stand, we can see the lead time is 3 weeks. So it means we have to order 3 weeks earlier, that is in week 4. And based on the master schedule table here, we can know in week to week what we have to do, the activities we have to do in every week. So here we can know that in week 1, week 2, week 3 we don't need to do anything. In week 4 we have to order, we have to make order of mounting stands with the quantity is 100. In week 5 we don't need to do anything. In week 6 we need to order 100 spindles and 50 bots. And in week 7 we have to order 200 lock nuts and 200 wheels. In week 8 we will receive, we don't need to order. Okay, we order 100 wheel assemblies be ready here in week 8, and we receive 200 lock nuts, 100 mounting stands, 100 spindles, and 200 wheels in week 8. And in week 9 we finish a 100 wheel assembly and finish 50 fiberglass and get ready to assembly the products. And then in week 10 we will have 50 finished products to deliver to the customer. So that is how we can use the combination between BOM and MPS. However, we still need to use the information from the inventory record. For example, we need to have 50 fiberglass board. However, in the inventory in the warehouse we already have 20, so we only need to order 30, right? So we need to use the information from the inventory master file to determine how the actual quantity we need to order. So inventory master file will include mainly inventory records, and it will show the items lot size policy, lead time, and the time phase data, and how we can calculate the on-hand stock at the period T. We will calculate two values. The first value is the on-hand stock at the end of the period, the previous period, that is T minus 1, plus the schedule of plans received in period T minus the gross requirement in period T. So we compare that value with euro, and we take the maximize of euro and that value. We will have the on-hand stock at the end of period T. So for example, we have 4 weeks. We have 4 weeks, week 1, 2, 3, and 4. So for example, I have week 1 is the on-hand stock, and at the end of week 1 is 200. Is in week 1, and in week 2 the schedule receive. What is schedule receive? Schedule receive is for example, we already order the products. However, they say that they will deliver it to us in a period of time. So in this case, for example, we make an order in week 1, but the supplier will deliver the product to us in week 2. So we will receive the product in week 2. So the schedule received in week 2, for example, is 100, and the gross requirement in week 2 is 150. So how much is the on-hand stock in week 2? We will calculate it as 200 plus 100 and minus 150. So we will have 150. So we see that 150 is larger than 0. So the on-hand stock in week 2 in this case will be equal to 150. However, if the requirement in week 2 is not 150 anymore, it's 500. So how much is the on-hand stock in week 2? We will calculate 200 plus 100 and minus 500. So we have the value is equal to negative 200. So we have the value is negative 200, and we can see that negative 200 is less than 0. So it means the on-hand stock in week 2 now is equal to 0. Okay, it's how we determine the on-hand stock in a period of time. And